Hi, Dave. Thanks for joining us today.
Thanks, Daryl, for having me.
Yeah, so I think Jordan already tipped kind of where I wanted to go with my first question. Your portfolio is vast and covers a lot of different consumer devices, obviously, and then also Project Kuiper, which when I first heard, honestly, I was surprised, and I would love to hear just to start, you know, how kind of. Oh, sorry, did you lose me there?
I did lose you. You're back now. I
Oh,
apologize.
Oh, no worries. So I think, yeah, what I was saying was just how does Kuiper fit in with kind of like Amazon's broader devices portfolio? Why does it make sense for it all to be kind of like housed, I guess, under you, besides the fact that you're probably a great executive?
Time will tell on the latter, but I think there's a couple things. One is I've since a pretty young age I've been passionate about space, so that is part. When you're passionate about something, I think things can gravitate towards you. This could fit under many leaders inside of Amazon, but secondarily, I think that. It's very easy when you talk about something like Kuiper to talk just about the satellites or how we're going to get things to space. But there's a lot of other pieces that go into what will make a customer offering for a constellation like this, and that involves equipment in the people's homes. It involves routers. It involves a customer terminal. It involves running a big service network and billing and reliability. And those are all things that, as part of my other part of my day job, we do for all our products. We have to run those kinds of things for Echo. We do those kinds of things for Arrow and Ring. And it kind of fits with the skill set, I think. It also involves a lot of manufacturing at scale. And, I think people underestimate the complexities of manufacturing. And I have a bit of that in my background as well.
Right. Yeah. So I mean, when you just mentioned one of the things that you've revealed some details on today, which is the customer terminal, right? And so you shared some of the work that Kuiper has been doing on that front, and what you've been able to achieve is make it much smaller than the typical receiver or terminal for use for satellite networks here on Earth. So can you talk a bit more about that and what the achievement is and what it means for the actual user experience ultimately?
Yeah, the goal of Kuiper is to serve, eventually, we hope tens of millions of underserved or unserved completely broadband customers. There's plenty of other broadband offerings, but there's places that just are hard to get to. But to do that, you have to think about the end-to-end business model as well of what this is going to be for a customer. And to make it scale to those kinds of numbers, it has to be affordable. It's just simple as that. And I look at it the same way I would look at a Fire TV. If we can get a Fire TV under $50, lots of people will buy it. If it's $200, a lot less people will buy it. And we made an architectural decision with Kuiper pretty early on for lots of interesting reasons to go with the Ka band.
Hmm.
The challenge of using Ka in the past, though, is it has led to much larger customer terminals because of the separation you need for the antennas. And that's fine if you're in a maritime situation or you're putting it on a plane. You can afford a $10,000 to $20,000 terminal that might be, a meter or plus in diameter. But that wasn't going to be possible for this. So we put some pretty audacious goals in front of the team as a milestone that we just crossed recently, a couple weeks ago, to effectively get a terminal incredibly affordable for customers in a self-service way at a size that hadn't been seen before. And I'm really happy that the team kind of got that first milestone behind them. And I'll show my age a little bit, but it's basically the size of a 33 LP. It's kind of 12 inches in diameter, and no, we've not. There might be something out there we don't know about. We've never seen anybody even close to that using the kind of bandwidth and spectrum that we are.
And you mentioned cost there. That so like yeah, the ones that you would see in commercial use $10,000. So what are these costs relative to that? Can you share any pricing or what you imagine pricing will be like?
Yeah, I don't know what the end customer pricing will be. We'll probably make that decision the day before we launch,
Closer,
which is
yeah.
still a ways away.
Right.
That's typically Amazon's pricing strategies. But I would tell you that it has to be affordable. That we don't, and so when we saw what was out there as state of the art, we set a goal that it couldn't be just 10 or 20% less expensive. That was not what we architected and what we've sort of prototyped now and achieved. We were looking for 5 to 10x decrease in cost. And we now have a path to that. And we think then we can make sure that there's an affordable, and again, the customer terminal is one part of an entire system, but it's an important
Right.
part. And we think that we'll be able to offer to a price point that, like I said, tens of millions of customers can afford, and it makes the business model work.
Great. And so what were the specific challenges that the team had to overcome from an engineering perspective here? Like how did you do this when so many other people were not able to? Is it just all about scale and the scale that Amazon affords?
Well, I think all these things start with people. You hire great people that have a curiosity and want to invent and aren't afraid of audacious goals. And I think, by the way, a lot of people speaking at your conference here and in the space industry in general share this characteristic. They sort of take science fiction and make it a reality. And I think a lot of the people on the Kuiper team have that similar want to invent. And some of the major challenges are again, we're using the Ka spectrum, is that typically in designs around solid state antennas, is that the send and receive had to be distanced pretty far apart because the range of spectrum in the Ka spectrum is pretty wide as well. There's advantages of that. You can get much higher bandwidth, but it often comes at the price of a much larger antenna. And we were able to take advantage of some of the nuances of how people use broadband. There's an inherent asymmetry of how people use broadband
Hmm.
in that they receive much more than they send.
Right.
And by doing that, the team was able to do, in a clever way, overlay RX and TX, receive and send in the same lattice. And by doing that, we were able to shrink down the size of antenna, reuse components, and bring costs down. But I would point out that the cleverness didn't stop there. Also, on the satellite themselves, we were able to make some specific modifications to the antenna and design there that works in concert with the ground terminal, customer-based ground terminal. And that also added to the system such that we could reduce costs even further in the customer terminal design.
And without the kind of significant trade-offs in terms of performance, right? Because I think you'd mentioned in the blog posts on Amazon that it's still getting 400 megabits per second transfer speed.
Yeah, and that, by the way, that was a little bit of a surprise. You don't expect your first design to kind of hit the initial requirements, and it did. So it's on a bench, and obviously we still have a lot of work to do. But
Right.
you're right. At 400 megabits per second, we think we can offer a unbelievably viable service to people that literally are, if they have broadband today, that it's running over twisted pair copper, and it's pushed to the very edge.
Great. And so you did mention also that there is a lot of focus on the launch part, but the other is more important. And I do want to kind of unfortunately go back to the launch part because it is a big question around Kuiper and when we'll start to see these satellites go up and kind of like how they'll go up. And so can you give us any updates about kind of progress towards that or what's been accomplished on that front through the year?
Well, it's kind of order of operations here. Our first important milestones were to get licenses. So we've gone through the ITU process, and more recently with the FCC license. And so now at that point, the clock basically starts ticking. So we have to get half our constellation up here in about 6 years. So that,
Right.
and our constellation, for those that aren't familiar, is 3,236 satellites in 3 orbital altitudes. We start at 590, go to 610 and 630 kilometers. And so I think that you can back into the schedule there. We have to have half our
Right.
constellation up in that period of time. So I'd say we are in the middle of our design phase. And the design phase, as you mentioned, it involves a lot. There's, again, the very sexy component of it is the satellite itself. There's a lot of work that goes into that, and certainly because at constellations of this size, it's not aerospace as usual. It is, right. You have to kind of reinvent aerospace, because we have to produce, not a satellite a year or a satellite every 2 years, but satellites every couple days, or maybe even every day, depending on how the launch capacity looks. And so that takes reinvention of not only how you think about and design the satellite itself, but how you're going to manufacture it, how you're going to transport it, how you're going to get it into a fairing on different types of launch vehicles and get it into space, obviously. So there's a lot of work there. But in parallel, we have separate single-threaded teams on the customer terminals I just mentioned, and also the overall network design. We're benefited a bit at Amazon by having this very, very good and reliable cloud service called AWS. And we're able to use many of the capabilities of that to help build out our backplane, help build out our network infrastructure, so that we can, you not only want to deliver great bandwidth to the customer, but you want a great quality of service across the end-to-end network that is not only fast and reliable, but also super secure. And so there's a separate team working on that as well.
Right. So, I mean, that's like a great point of differentiation, I guess, if you're looking at competitors in the market, right? Like if you're looking at SpaceX and Starlink, they don't have that expertise in-house, I guess, and they're not building that kind of like hand in hand with the other. They have to build that all from scratch. So that seems good, but it does seem like you're also going to require, like, how, I know the question is like, is Blue Origin going to be kind of the launch provider? Are they going to be doing in volume? Are they going to be doing kind of custom vehicles? Because it's, when you talk about it, it's like this, wow, you're right. Like the amount of satellites you got to put up and the pace at which you got to put them up, like that seems similar in terms of effort and scale to something like Starlink, right? Which is basically, they're able to do that because they're like, well, we're just going to go throw our rocket up every week and a half, right? So is that a part of the consideration? Can you tip the hand at all in terms of like Blue Origin's involvement, or no?
Well, let me tell you, there's two questions there. I think the first one, which is, is it a necessarily competitive advantage to have AWS in our networking? My view and Amazon's view is the more constellations, the better. This is hard, and no one constellation is going to serve the number of unserved people out there today. And by the way, we also need really successful 5G networks, and we need really successful coax networks, right? And Amazon and our customers benefit from a better internet. And we will be one part of that, but I hope there are a dozen other constellations that do it safely, reliably, and and if that happens, consumers will benefit. That being said, we think we have many of the components and pieces, not the least of which is a balance sheet to afford this. This does not come with a small price tag. No. We've already committed $10 billion to this effort. It may require more, but that's what I think. That's the kind of good project that Amazon can do. It's hard for a company that's 4 people in a garage to put up a constellation. It's going to be very difficult. And so those are the kind of problems we would hope, and you would hope Amazon can tackle. And then to the second question about launch capacity, we're launch agnostic. If somebody has a rocket out there, give us a call. One of the reasons we thought the time was right to do a constellation now is some of the dynamics happening in the launch industry. Every day we see a new demonstration of reusability. Every day we see a new demonstration of breakthroughs in better engines, whether that's Raptor or BE4. Every day we see significant improvements in the number of people and how reliable they can get to space. And if you just compared that today to 10 years ago, you would not have green-lighted a project like Kuiper, because those dynamics in launch capacity, reusability, et cetera, make it much more viable. But net, listen, will I hope Blue Origin can provide some launch capacity? Yes, but I hope others will too.
Great. Yeah, I mean, we just had a panel. I don't know if you saw it, but I was talking to Chris Kemp from Astra, who just launched, and Tim Ellis from Relativity, and also Mandy from Virgin or from Vox from Virgin Orbit. So like, you've got tons of launch providers coming online, and you're saying these are all opportunities for you, for providers, for service providers, for Kuiper.
Yeah, it's
Depending on payload
when you have
capacity and
when you have to put 3,200 plus things into space, you will need lots of launch capacity, and our hope is that it's not just one provider; that there'll be multiple providers.
Great. And then just so on the other side, back to the consumer side. So, you know, we're talking about, it sounds like when we're talking about the satellites, we're basically talking about towers almost, right? Like it would be the equivalent of talking about tower construction and tower infrastructure for a cellular network. Like, it's okay. Most people don't talk about that, think about that most of the time. So let's talk about the other end, which is kind of consumer delivery. We talked about the antenna, but actually,
You broke up there again. I'm sorry, I did missed a bit of the question.
oh, another one.
Yeah.
So when it comes to service delivery, are you going to kind of go at your own, or are you going to work more in a partnership fashion, like, say, Alphabet's Loon has done, right, where they're working to build out networks with existing network providers?
Yeah, I think the tower analogy is an interesting one. It'd be if you were putting towers into, the vacuum of space and cold with radiation, but close. But the point is, I think that a network like this has multiple purposes. I think we will, in certain parts of the world, certainly provide an end-to-end customer solution, where Amazon can show that that's a great service to customers and we can offer at a good price point. I think equally there's opportunities to use this kind of network to further other sort of universal access initiatives. The nature of our network is that it's not going to be for a mobile handset. It just won't work for that. It might work for some mobile solutions, but it won't work for anything that's a handset-based solution. And so, but if you have to put a 5G tower out in the middle of call it central Washington, which is not that far away from here, it's very expensive to lay fiber there, get power there, and so there's all sorts of opportunities for backhaul and things like that too. And there might be parts in the world where it looks more like a wholesale model. I think the Kuiper network's being architected in such a way that it can be flexible that way. Our initial will be to run a consumer-based service, but over time, I think all those are opportunities, and certainly we're open to talking to anybody about them.
Great. And can you talk just a bit more about, you mentioned earlier sort of like some of the people on the team. Can you talk a bit the progress of the team and the headquarters? Because I know you've created a dedicated headquarters for it. You were hiring. Has any of that been affected at all by sort of the pandemic and COVID-19, or are you still hiring? Are you still ramping those operations? How's that going?
Yeah, we started the year about 150 people on the project. I think our goal to end the year is about 3x that. We're kind of on that path, plus or minus a few people when they start. So I think given the headwinds of the pandemic, I think the team's done a good job bringing on really good talent, and especially the experts we need to find in this space.
Right.
They're not everywhere. They're not generic. They're specialists. And so we've made good progress there. But listen, if anybody wants a job on a cool project in space, just email me. We're hiring. The team's got to get bigger. But beyond that, I think also you mentioned having facilities. We just opened our facilities in Redmond. Obviously, we're having to limit the number of people that can use those facilities now to keep them safe in the sense of the pandemic. But the reason it needed dedicated facilities is the equipment needed to test and service and build prototypes of this nature are just very different than it would be to build an Echo or even a robot in one of our fulfillment centers. They're just very different. We need vacuum chambers, and we need very, very big antennas to test the radio frequencies, and so the team's done a great job building out those labs. We're not completely done, but the facility is open, and as you saw with the customer terminal, we're making progress. And I think over the coming quarters and years, you'll see us talk a lot more about the other big milestones that we have ahead of us. There's a lot of invention ahead of us. I would also point out that I'm sure that we'll make some missteps and we won't get it all right, but today, I feel pretty optimistic about the trajectory that the team's on.
Great. Well, Dave, you seem like you personally really love space. So I will ask, is there anything else that you want to tip for Amazon space ambitions, or is it Kuiper the focus for now?
Well, I think Kuiper's pretty big ambition. So if there was anything else, I'll leave it as a to be determined for a later conversation. But we're always inventing. I'm sure there'll be something new. But for now, Kuiper's got our full attention.
Yeah, plenty ambitious. Thanks very much, Dave.
Thanks for your time, Daryl. Appreciate it.
For centuries, space has captivated our curiosity. We've reached for the sky and beyond, looking for new ways to understand our planet and move humanity forward. And over the last 60 years, Maxar has helped visionaries, big and small, do just that. We design, build, and operate innovative space infrastructure and systems for Earth intelligence, communications, and space exploration missions. Our Earth observation satellite technology is revolutionizing how we identify, understand, and predict change at speed and scale. Maxar communications satellites and systems enable next-generation connectivity in the most populous and remote areas of the world. Our innovative approach to spacecraft and high-power solar electric propulsion will expand humanity's reach with sustained crew missions on the Moon and eventually on Mars, where Maxar robots are already helping to unlock secrets of the Red Planet's mysterious past. Soon, Maxar robotics will refuel, service, and assemble spacecraft on orbit. Introducing new capabilities that will improve the safety and sustainability of space and life on Earth. Put space within reach. See what's possible.